In this section, we're going to look at the meaning of the parameters m and q in the gradient intercept form. We have seen there are two main forms for a straight line. One is the standard form, ax plus by plus c equals 0, for example, 2x plus 4y plus 3 equals 0. And the second one is the so-called gradient intercept or slope intercept form, y equals mx plus q. So for example here, the same line written as y equals minus 1 half x minus 3 quarters. For practical purpose, we typically use this gradient intercept form. And these parameters m and q, they have very meaningful interpretations. The m is the slope or gradient of the line, in German die Steigung. So when you look at this line, well, how is the slope defined, die Steigung? We said always the altitude here divided by the horizontal distance, so delta y by delta x. So the line L passing through these 2 points A and B has the gradient delta y, which means yb here, yb minus ya, that's the delta y, divided by the delta x, which is then just xb minus xa. Here, xb minus xa, this distance. Q is the so-called y-intercept of the line, in German y-Achsenabschnitt. This means this is where the line intersects with the y-axis. So this point has the coordinate 0, q. Here we see it. Here it is at q. In other words, m tells us the direction of the line. So, and q tells us its location. M is the gradient, so it tells us how steep the line is. So when I know the gradient, I know it looks like this, or if it's steeper, it can look like this. And then the q tells us, once I know it has this gradient, where do I have to put the line with that gradient? Well, through this point, and then I get this one line. Let's look at an example to understand this better. We are given the 2 points A and B here, 1, 2, and 6, 4, and we're looking now for the straight line passing through these 2 points for its equation in gradient intercept form. So what we're looking for, the line L has the form y equals mx plus q. So let's find first the m. Well, m is delta y divided by delta x. We said that before. It's this gradient. So it's this divided by this. And we said the delta y can be calculated as yb minus ya and delta x as xb minus xa. So we insert now the values. Yb is 4, ya 2, xb is 6, and xa is 1, and we get m is 2/5. So let us insert that now into the line, into the equation of the line. So we get the equation of the line is y equals m is 2/5, so 2/5 x plus q. What I have done, I have taken this m 2/5 and just inserted for the m the 2/5 here. And now we need to find the y-intercept. And the idea here is just we know now already the line except for this q. So we say, well, the point A, for example, we can choose one of the 2 points. The point A lies on the line, so its coordinates fulfill the equation. So we use the fact A is element of L. Its coordinates fulfill the equation. This means I can insert the coordinates of A. So y of A is 2, the y coordinate of A. So 2 equals 2/5 times the x coordinate of A times 1 plus q. Well, to solve that, I have just to subtract 2/5, and I get q is 8/5. And so I have found the equation of the line is y equals 2/5 x plus 8/5. We see now the principle or recipe how to find the equation of a line given by 2 points A and B. The equation in gradient slope form. First we find just the gradient m as using this form here, and then note here it doesn't matter if we write yb minus ya divided by xb minus xa, or yb minus ya minus yb divided by xa minus xb. The important thing is just we have to use the same order in the numerator and the denominator. Here it's b minus a, so it has to be the same here. Here it's it's a minus b, so here also a minus b. So this you can see that also by what happens from here to here is we expand by -1. So when I expand this by -1, I get minus yb plus ya, so ya minus yb, and the same happens on the bottom. Okay, that's the way to find m, just as this delta y divided by delta x. And once I have m, I insert just one of the 2 points, a or b, into the equation that I've got by then, and I have ya equals m times xa plus q. The m is already known from step 1, so I have only one unknown left, the q, which I can now get from this equation. In the second example, let's look at the second main topic or question that is being asked in relationship with these straight lines. This is, we want to draw the line given by its equation in gradient intercept form. So the line equation is y equals minus 2/3 x plus 4. So let us draw it. Well, we know that the y-intercept q is 4. So q is 4. This means we have this y-intercept is the point 0, 4. So we know the line passes through this point here. The gradient m is minus 2/3. I can rewrite that as minus 2 divided by 3. And now remember that this is the delta y divided by delta x. So here the delta y is minus 2 and delta x is 3. So what we do now, we use now this delta x here. We use now this delta x and delta y. So I start here at this point that is on the line. I know now I can draw this triangle. So I go 3 to the right. I'll use another color. Just this is now my delta x. And then I go delta y, which is minus 2, which means I have to go from here to down, and I arrive at this point. So I found now a second point of the line, and now simply I can connect these 2 points, and I get the line. I have drawn the line here. So from this example, we see the principle or recipe how to draw a line given by its equation in gradient intercept form. We first draw the y-intercept, which is 0q, and then we use the gradient m delta y divided by delta x to find a second point by moving delta x to the right and delta y up. And if the delta y is negative, we just have to go down. And that way we find the second point, and then we just can connect the 2 points. Another way to use this gradient m here, the minus 2/3, for example, would be instead of going 3 to the right and then minus 2 down, we could also just say we go 1 to the right and minus 2/3 down, or 2/3 down here. Because we can look at this as being minus 2/3 divided by 1. So then the 1 is the delta x and the whole minus 2/3 is the delta y. Both is correct. Typically this way that we did it is better because otherwise you get the second point very close here, and if you don't draw it precisely, your line might not look very nice. So here comes some important notes. The gradient m is yb minus ya divided by xb minus xa, or we can write it the opposite way around, ya minus yb divided by xa minus xb. What is important, the order has to be the same in the numerator and in the denominator, Zähler und Nenner. If m is larger than 0, what does this mean? It means that this line is ascending, steigend, seen from left to right. So this line here is ascending. When we always go from left to right, the gradient m is larger than 0. When we take, for example, here the triangle, we have delta y, 2 divided by 1, so we get 2, which is larger than 0. When the m is smaller than 0, the line is descending, fallend, again seen from left to right. So this line is descending. When we take here the triangle, for example, here to here, or in, let's draw it like this, here, our triangle. So we go 3 to the right, 1 down, that means minus 1. So I have minus 1 divided by 3 is minus 1/3, that's smaller than 0. So if we are on a point on the line, and for example here, and we move 1 to the right, we have to move exactly m units up. Here, when we're here on the point, we go 1 to the right, we'll have to move m units up. Well, in this case, we said the m is negative, minus 1/3, we said a moment ago. So moving minus 1/3 up means 1/3 down, and you see I get back on the line again. If m can be written here, is written as delta y divided by delta x, well, if I move delta x to the right, I have to move exactly delta y up. So 3 to the right, minus 1 up, or 1 down. Or here we had 1 to the right, 2 up. So this is the basic understanding of the gradient. So for example, if m is 4, well, we can say 4 is 4 divided by 1. So when moving 1 to the right, we have to move 4 up. And here in the second example, m is minus 1/3. Let us rewrite that always. Let's take the minus here from the front into the numerator, Zähler. So we have minus 1 divided by 3, which means when moving 3 to the right, we have to move minus 1 up, which means 1 down.